welcome to another day of flexible learning here with Algebra 1. We're going to continue to talk about exponent rules, more specifically some exponent rules that have to do with division. So let's dive right in. Here is an example. I've got 5 to the 6th divided by 5 to the 4th. To help me better simplify this, I'm going to factor this out. So I'm going to actually expand this 5 to the 6th here. Remember, 5 to the 6th is really just telling me a shorter way of writing 5 times 5 times 5 times 5 times 5 times 5. Whoa. 1, 2, 3, 4, 5, 6. Yep, we got 6 5s. And 5 to the 4th is really just another way of saying 5 times 5 times 5 times 5. Right? I've got 1, 2, 3, 4 5s on the bottom. Now, thinking about last week when we were simplifying rational expressions, look, these are the factored forms, so now I can start canceling some things out on the top and bottom, right? I see a couple big ones, or giant ones. So here's a giant one. Here's a giant one. Here's a giant one. And I've got another giant one. That means all these 5s actually just cancel out, right? And I've canceled out all the 5s on the bottom, so what am I really left with on the bottom? I'm left with 1. And at the end, I have 2 5s left up top. I've got a 1 here on the bottom, so I'm really just left with 5 squared. Now let's look at how many of these 5s we canceled out. If you notice, we canceled out 1, 2, 3, 4 5s on the bottom. And what we were really left with, if you really look at it close, was we were left with 5 to the 6 minus 4, right? Isn't 6 minus 4 2? So what we had up top here in the numerator, we subtracted the denominator from it. And so dividing these is very similar to yesterday when we were multiplying them. So the new rule today is the quotient of powers. And the quotient of powers says that if I'm dividing two terms that have the same base, this x is my base, I can subtract their exponents. And more specifically, we're subtracting the exponent in the denominator here from the exponent in the numerator. So let's do another example. I've got z to the 5th over z to the 2nd. According to my rule, I've written it over here in the corner. That's a suggestion. Write these rules out somewhere on your paper so while you're doing them, it's a lot quicker and you can kind of recall those rules. According to my rule, I can say, and I'll do this in a different color, that z to the 5th over z to the 2nd is really just equal to z to the 5th minus 2. And my simplified answer is z to the 3rd. All right, let's do a bigger example. Again, I've written out my formula over here in the right-hand corner. That's going to make it easier for me to kind of find what I need. And then my formula says when I have the same base, I can subtract those exponents. So I'm going to look for things with the same base. I see a base of a on the top and a base of a on the bottom. Now, this a on the bottom doesn't have an exponent, or does it? It does. And its exponent is really just a to the 1st. A to the 1st. And that means in my final answer, I'm going to have a to the 5 minus 1. And I'm going to look for another set of bases that match. I see these b's. In the numerator is 10, the denominator is 2, so I'm going to do b to the 10 minus 2. And you might be wondering, what do I do with this 3 and this 6? They don't match. They're not matching bases. I'm just going to simplify it like I would a fraction. So what's 3 over 6? It's 1/2. Good, and I'm going to write that out front because that's just the standard way of writing it. Finally, I'm going to write this in its simplest form. The answer would be 1/2 a to the 4th, b to the 8th. All right, this example looks a little like one from yesterday, the power of a power, but that was with multiplication, and now we're doing division. So how does this look with division? Well, it looks very, very similar to the one with multiplication, but let's expand this out, right? So this power of 3 tells me that everything in here is multiplying 3 times. So that looks like a squared over b to the 4th times a squared over b to the 4th times a squared over b to the 4th. Look, I'm multiplying everything straight across, right? When we multiply fractions, we multiply straight across. And when I multiply exponents, we add exponents, right? So I've got a to the second, a to the second, or a plus 2 plus 2 plus 2 over b to the 4 plus 4 plus 4, which turns out to be a to the 6th over b to the 12th. But let's take a look at our original expression. Isn't a to the 6th really just another way to write a 3 times 2 and b to the 12th? Can I write that as b to the 4 times 3? I think I've found us a new rule. Let's check it out. Power of a quotient. When you have a power of a quotient, you are going to multiply every exponent inside the parentheses by that number outside. So in this case, I've called that number outside c, right outside these parentheses. I multiplied the a and the c, and I've also multiplied this b and c. From there, we would simplify this however it turned out. So let's look at some more examples of this and try it out. I went ahead and wrote down the rule down here to help us out. And let's look at this. Let's try to do it the quick way. I need to multiply every exponent inside this set of parentheses by 3. Don't forget, this 2 actually has an exponent of 1. And so does this b. We don't normally write them, though, because any number to the first power is just itself. But don't forget to remember that that exists. All right, so if I'm following this rule down here in the corner, I know that I have 2 to the 1st times 3, a to the 5th times 3, all over b to the 1st times 3. Now I'm going to simplify this down. All right, so that means my final answer is 2 to the 3rd, a to the 15th, all over b to the 3rd. All right, hang in there. We've got 2 more examples. Here we go. Another one. Here I'm going to put this formula down here in the corner. And here we go. We're going to multiply every exponent in here by 2. Don't forget, this y is the same as y to the 1st. Let's go. I've got x to the 5th times 2, y to the 3rd times 2, over x to the 3rd times 2, y to the 1st times 2. I'm going to simplify that down here, so that means I have x to the 10th, y to the 6th, all over x to the 6th, over y to the 2nd. I want you to take a second. Am I done with this? No, good, I'm not. I can still simplify this because I have some like bases on the top and the bottom, right? I've got an x, and I've also got these y's. So that means I can use my other rule, right? The quotient of powers rule. So here we go. My quotient of power rule says x to the 10 minus 6, y to the 6 minus 2. My final answer would be x to the 4th, y to the 4th. And that's it. That's my final answer. Last problem we'll do together. Let's try this one out. Don't forget, if they don't have an exponent, they really do. It's a 1, right? This is 2 to the first, because 2 to the first is just 2. And I've got 4 to the first and x to the first. So I just want to write them as placeholders so I don't forget to multiply them by 2, right? I don't want to forget to multiply those exponents by 2. So let's get rid of these parentheses. Let's multiply all these exponents by 2. That's going to give me 2 squared times x to the 3 times 2 all over 4 squared x squared. So I didn't write 1 times 2 because 1 times any number is just itself. So for those 3 exponents, I just automatically went to 2. I've got 1 exponent I need to simplify, and that's up top in the numerator. So I've got 2 squared x to the 3 times 2 is really just x to the 6th. 4 squared x squared. So I'm noticing some bases that are the same. That's those x's, right? You see these x's right here? Since they are the same, I can use that rule, the quotient of powers rule, and I can say that x to the 6th minus 2. And then I've got 2 squared over 4 squared. For right now, I'm just going to write, 2 squared is 4. And I've also got 4 squared. 4 times 4 is 16. So I've got 4/16 times x to the 6th minus 2. I'm going to keep simplifying these things. Can we simplify the fraction 4 over 16? Yes, we can. It's 1/4. Very good. 1/4. X to the 6 minus 2 is x to the 4th. And that's the final answer. That's it. Quick side note, one other way to write this, if you were wondering, is yes, you can write this as x to the 4th over 4. I think it's worth mentioning that these two things are the same, but either one will work as an answer. Good luck on your assignments today. Reach out to your teachers if you have any questions at all.